Welcome to Science Views from the Valley. I'm your host, Dr. Kelly Kassan. Science Views from the Valley is a monthly program that will explore interesting science topics and how they relate to the San Luis Valley and the Upper Rio Grande region. Today's topic is an animal that people love to hate, spiders. Now, if you are afraid of spiders, you are not alone. Arachnophobia is the #1 animal phobia, with snakes coming in at a very close second. But spiders do benefit us in a number of ways. They eat a lot of pest insects that would otherwise destroy crops. They also eat mosquitoes that carry a variety of human diseases, including Western equine encephalitis, yellow fever, West Nile, and Zika. In fact, mosquitoes, through their incredible abilities to vector diseases to new hosts, is estimated to cause nearly 1 million deaths from mosquito-borne illness each year. Spiders, however, will kill less than 10 per year. In fact, only 1 death to spider bites has been reported in Australia in the last 37 years. And there are more things, including spiders, that can harm you in Australia than anywhere else in the world. So in my opinion, people should run screaming from mosquitoes, not spiders. Spiders belong to a large group of invertebrate animals called arthropods. Arthropod is Latin for jointed foot, and indeed all arthropods have jointed legs and feet. Arthropods also have a hard shell called an exoskeleton, which supports and protects the animal. Within the arthropod group, we have several smaller groups that share similar characteristics. Arachnida, which is the group that spiders belong to, also includes camel spiders, scorpions, harvestmen, also known as daddy longlegs, and even the tiny pseudoscorpions, ticks, and mites. What all arachnids have in common is 8 legs and fang-like structures called chelicerae. Spiders are divided into 3 subgroups: the mesotheli, the megalomorphs, and the araneomorphs. The mesotheles are believed to be the oldest living spider group and have characteristics that are not seen in the megalomorphs or the araneomorphs. These characteristics include a segmented abdomen with spinnerets in the middle instead of at the end, and small hardened plates on the back of the abdomen. Most mesotheles build burrows with trapdoors. Some even make silk trip lines that radiate from the trapdoor. These trip lines, when triggered, signal to the spider that prey is near. Megalomorphs, like the mesothelials, have downward pointing fangs and 4 book lungs, which are the respiratory organs of spiders. Unlike the mesothelials, megalomorphs do not have a segmented abdomen, nor do they have the hardened abdominal plates. Megalomorphs include the tarantulas, which are a common sight here in Colorado, particularly in the late summer and fall when the tarantula migrations occur. Megalomorphs contain some of the largest spiders in the world, including the Goliath bird-eating spider. The Goliath bird-eating spider can obtain weights of approximately 6.2 ounces and body lengths of approximately 5 inches. Female megalomorphs are extremely long-lived, living up to 15 to 25 years on average. The oldest recorded was in Australia, where a megalomorph species lived 43 years. Araneomorphs are the spiders people are most likely to encounter on a daily basis. This large spider group includes the jumping spiders, the wolf spiders, the widow spiders, and many other common species. Araneomorphs, unlike the mesothelials and the megalomorphs, only have 2 book lungs, and their fangs are pointed horizontally. So araneomorphs pinch their prey, while the megalomorphs stab their prey. The people who name and classify living organisms, taxonomists, have recorded 48,000 different species of spiders worldwide. All of these spiders are carnivorous, meaning they eat other organisms. Some spiders are reported to scavenge dead prey, and a few spiders have been known to sip at plant nectar, which is the sugar water that plants produce. But no spider is truly herbivorous, meaning that they consume only plant material. Spiders hunt their prey in a variety of ways. Many spiders build webs, including the orb weavers, the grass spiders, and the widow spiders. Ogre-eyed spiders will build silken nets and throw it on their prey. Boa spiders will make a single silken thread with a sticky glob of silk at one end, and they swing it to capture a passing moth. Wolf spiders and jumping spiders, however, do not build webs, but they will chase or ambush their prey. The spider group I study, the fishing spiders, do not use web either, but will place their feet on the surface of the water, feeling for vibrations caused by prey movements on the water surface. Once they sense the vibrations, they will move towards the source and attack it. Spider webs are often unique to the species, so much so that arachnologists, the people who study spiders, can identify the spider based on the type and structure of the web. Orb-weaving spiders, for example, make the large circular webs with the gradually smaller circles as you go towards the web's center. Widow spiders make a tangled mesh of silk called a cobweb. Grass spiders make large sheet webs with a funnel at one end, where the spider hides until it senses that the web has trapped an insect. Bowl and doily spiders make a bowl-shaped web that sits above a flat sheet web. When insects fall into the bowl, the spider, which is lying underneath the bowl, will then bite it through the web in order to paralyze it. The protein fibers that spiders use to build webs, spider silk, is an amazing material. Spider silk has a very high tensile strength, which allows it to absorb a lot of energy before breaking. Spider silk is approximately 5 times stronger than steel, though not as strong as Kevlar. Spider silk also has a high ductility, which allows it to undergo considerable deformation before fracturing or breaking. For example, spider silk can be stretched up to 5 times their length before fracturing. This combination of high tensile strength and high ductility makes spider silk tougher than both steel and Kevlar. Spider silk, because of its flexibility and high toughness, was used for gun sights during World War II because it could withstand the vibrations of gunfire better than thin wires. The high tensile strength, ductility, and lightweight properties of spider silk would make it very useful for making a number of products. But collecting enough spider silk to make industrial production of these products is problematic because how little silk each spider produces each day. 2,500 silkworms will produce 1 pound of silkworm silk. But you need 27,000 spiders to produce 1 pound of spider silk. Some scientists have explored artificial means of producing mass quantities of spider silk. One method was by placing the spider silk genes into different organisms so they would produce spider silk proteins. Bacteria, tobacco, potato plants, even goats were genetically engineered to produce spider silk. Unfortunately, most of the spider silk produced by transgenic organisms were either a lower quality silk that did not have the same tensile strength and ductility of natural spider silk, or the transgenic animals did not produce spider silk proteins in quantities that would make it commercially feasible. For example, the genetically engineered goats produced the highest quality spider silk, which had the trademark name BioSteel, but obtaining the quantities needed to mass-produce items have so far eluded scientists. Spiders have a bad reputation due to being venomous. It's true that all spiders have venom glands, but only a few spiders have venom that is poisonous to humans. The 2 most poisonous spiders in the world are the Brazilian wandering spider and the Australian funnel-web spider. A fascinating fact about the venom of the Australian funnel-web spider is that it is toxic to primates, humans, and insects, but does not affect other mammals. This spider could chomp all day on your cat, and all it will do is annoy your cat. The United States is actually pretty lucky, having only 2 spider genera that are poisonous, Lactrodectus, which is the widow spiders, and Loxosceles, which is the brown recluse. Some people also report having a sensitivity to the yellow sac spider venom. People who are allergic to other arthropod venom, like bee stings, may have a sensitivity to the venom of other spiders. Though the hobo spider, a large spider found in the Pacific Northwest, was long thought to be toxic to mammals, including humans, subsequent studies of the effects of hobo spider venom on humans revealed that it is not toxic after all. 3 species of black widows exist in the U.S. Lactrodectus hesperus is the western black widow. Lactrodectus mactans is the southern black widow, and Lactrodectus variolus, the northern black widow. Here in Colorado, we only have the western black widow. The venom of widow spiders is a neurotoxin which affects the nervous system. Common symptoms of a neurotoxin include muscle pain, chest tightness, stomach cramping, and nausea. More severe symptoms can include anxiety, breathing and speech difficulty, and sweating. How a person reacts to a black widow bite is highly variable. Some may experience very mild symptoms. Other people may have severe enough symptoms to be hospitalized. But very few people die to black widow bites, according to the American Association of Poison Control. Approximately 2,200 people are bitten by black widows every year. But the last death due to black widow venom in the U.S. occurred in 1983. One reason for the low death rate is because many spiders dry bite when they are defending themselves. They do not inject any venom in the bite. This venom, which is a cocktail of proteins and other chemicals, require a lot of energy to make. So spiders will avoid wasting the venom that they need to hunt prey. The brown recluse, however, has a necrotic toxin. A necrotic toxin contains enzymes that causes damage to the blood vessels and cell death. The bite itself is usually painless due to the small size of the spider. But after approximately 3 hours, the site of the bite will redden and a white blister will form. In severe cases, a bluish color will form near the bite site as the surrounding cells die. This bullseye bite is indicative of a brown recluse bite. The only poisonous spider native to Colorado is the western black widow. The other known poisonous widow spiders have ranges that are located either further south or to the northeast. The brown recluse natural range is mostly in the deep south and does not extend west of Oklahoma. Spiders use venom to subdue their prey, a method that is also used by centipedes and some other insects. But their method of consuming the prey is somewhat unique. While most animals digest internally, spiders do all of their digestion externally. Though it may appear that the spider is sucking the bodily fluids from their prey, in actuality they are injecting digestive enzymes into the prey and later sucking the digested meat fluid through their fangs. Some spiders will digest everything except insect exoskeletons and wings. Other spiders, like the fishing spiders I study, will use the small teeth on their chelicerae to chew the hardened exoskeleton, injecting more enzymes to digest every morsel of flesh from the prey's body. When you think of this, this is not unlike humans sucking the marrow from bones. Though spiders are always predators, they can also be prey. Many birds, for example, find spiders to be quite tasty. Spiders defend themselves from predators in several ways. One way is through mimicry. Some bola spiders, for example, including those I have seen in Texas, can pull in their legs and form a grayish-white lump that resembles bird dung. Birds will not eat their own dung, so they avoid the bola spiders. Other spiders mimic ants. Ants taste nasty to most other animals due to antifungal chemicals they have in their exoskeleton. Some ants have stingers with venom attached, like the fire ants, so many predators will actually avoid attacking and eating ants. So predators will also avoid a spider that happens to look like an ant. Another common spider predator are wasps, in particular spider wasps. Tarantula hawks is one example of a spider wasp that preys on spiders. Tarantula hawks can paralyze spiders by stinging them with venom. They then drag the paralyzed spider to a burrow where it will lay a single egg on the spider. The tarantula hawk larva that hatches from the egg will then consume the still living but paralyzed spider. The tarantula hawk larva will feed on the non-essential tissues of the spider in order to keep it alive as long as possible until the larva can pupate to become an adult wasp. One spider myth I often hear when I give talks on spiders is that the daddy longlegs has the world's most powerful venom, but the fangs are too small to bite you. But in the U.S., daddy longlegs are not spiders, but harvestmen. Harvestmen are arachnids, but they are not spiders. How can you tell if you have a harvestman or a spider? All spiders have two major body parts, the cephalothorax, which is attached to the 8 walking legs and the abdomen. The connection between these two body parts is constricted, so it looks like there are two separate body parts. But the connection between the cephalothorax and the abdomen in harvestmen is very broad, so it looks like the cephalothorax and the abdomen are fused into a single body part. Another reason that this myth is false is because harvestmen do not have venom glands in their fangs, since they are mostly omnivores, eating small insects, plants, and fungi. Some harvestmen are also scavengers, preferring to eat dead organisms and dung. So harvestmen do not have a need for venom. Harvestmen do produce a strong-smelling defensive chemical from scent glands. This chemical may smell bad, but it is not poisonous to humans. So how did this myth come about? According to my colleague Bill Shear, the myth is a result of the same common name being used for different organisms in different countries. In the U.S., daddy longlegs are harvestmen. In Britain, daddy longlegs are crane flies, which look a lot like mosquitoes on steroids, but in reality are quite harmless. But in Australia, the daddy longlegs is a tangleweb spider called Pholcis phlangoides. This spider is not harmful to humans, though they are known to eat the Australian redback spider, which is Australia's version of the black widow. Since the redback spider is poisonous to humans, the fact that tangleweb spiders eat these redback spiders makes them look more dangerous than they really are. Another spider myth is that female spiders will always kill and eat their mates. While many female spiders do attack the male after mating, most males are able to get away and live to mate with a different female. Sometimes the male will sacrifice itself to the female. This behavior is seen in the Australian redback spider. The Australian redback male, after mating, will do a somersault over the female, landing in front of the female's fangs. This allows the female to consume the male quite easily. This behavior is believed to delay the female from mating with a different male, ensuring that most of this female's offspring will be the progeny of the sacrificed male. But not all females will attack her mates. Some species of grass spiders, for example, will cohabitate with their mates for 2 weeks after mating. I once came across a cohabitating pair of grass spiders during a spider collection trip in the Smoky Mountains. The sight of the two spiders cuddled together in the grass spider's funnel was quite adorable as spiders go. One spider-related news that you may have heard about is the tarantula migrations in Colorado. Each fall, male tarantulas travel across the grasslands of southeastern Colorado near La Junta. The spider is Aphonopelma hensai, commonly known as the Oklahoma brown tarantula, unless you live in Texas, where it is called the Texas brown tarantula. This spider is non-poisonous to humans and is rather gentle. I have 2 female Texas brown tarantulas at home. given to me by nervous citizens during one of these migrations in Texas. The male spiders migrate because they are looking for females, which do not stray far from the burrows they dig in the ground. So the male has to travel from burrow to burrow, looking for a female that will find him attractive. Once he detects a female tarantula's scent, the male spider will go to the burrow and tap on the entrance. This causes the female to lunge out. When she lunges out, the male grabs the female, mates with her, and if he's lucky, will live to search for another female. Unfortunately, even if the male is lucky enough to escape the voracious appetites of his mates, they do not live for more than a few months after mating. Though arachnophobia is the #1 animal phobia today, many ancient cultures did not fear spiders. Stories of spiders doing great things for mankind date back to biblical times. One story in the Torah tells of a spider that protected David from King Saul by building a large web across the entrance of the cave where David was hiding. King Saul, believing that no one could enter a cave without destroying the web, did not search that cave. The Hopi included spiders in their creation story. The spider woman was the goddess of the earth. She, along with the sun god, created the first man and woman by molding them from clay. The Cherokees have a legend that a grandmother spider brought light to the world. This legend states that in the beginning, everything was dark because the sun was on the other side of the world. The animals met and agreed that someone needed to go and bring the sun back so the animals could see. The possum and the buzzard tried but ended up charring their tails and feathers. But grandmother spider made a bowl of clay and used her 8 legs to roll it to where the sun was sitting, weaving a web along the way. She gently placed the sun in the clay bowl and rolled it home, following her web. She traveled from east to west, bringing the sun with her. In other science news in the Valley, if you like watching the night sky, and I know I do, we have a meteor shower coming up on October 20th. The meteor shower is the Orionids, which are the result of debris left over by Halley's Comet. Halley's Comet is a short-period comet that passes the Earth as it orbits the Sun every 75 to 76 years. The last time we saw Halley's Comet was in 1986 and expected to return to the Earth in 2061. Nearly all comets are made up of ice, frozen gases, dust, and rocks. Many astronomers refer to comets as dirty snowballs. As these comets near the Sun, the frozen gases and ice thaw, releasing the dust and the rocks. This leaves a trail of debris that the Earth, during its orbit, will pass through. This year should be an average year for the Orionids, so you should see about 10 to 20 meteors per hour. The moon will be crescent, not quite a quarter moon, so the skies will be relatively dark. If you enjoy searching for planets, Mars will be at its brightest after October 13th and will be present in the evening sky along with Jupiter and Saturn. Venus can be seen in the morning sky approximately 3 hours before sunrise. I hope you enjoyed learning about spiders today. Perhaps when you see one, you will no longer fear them as much. An old English folk saying states that if we find a spider on our clothing, it means money is coming our way, so think of them as good luck charms. One more item I'd like to mention before I go. Science Views from the Valley is a show for everyone. I encourage you to look at the nature around you. I would love to hear your science questions and share them and my answers on future shows. If you have a science question or have a spider or insect that you would like to have identified, feel free to send your questions and animal photos to spiderwomankrza@gmail.com. I also invite you to participate in the San Luis Biodiversity Project that I started this year. This project aims to identify the animal and plant species in the San Luis Valley. Your observations and photos of what you have observed would be very helpful to this important project. Thank you for listening to Science Views from the Valley here at KRZA. Catch my next episode next month when I'll be discussing deer and why mule deer love to congregate in downtown Alamosa in the fall. This show was created and written by me, Dr. Kelly Kassan, and I would like to thank the staff of KRZA for their help and advice. Good day.